In this slide, we will learn how to prepare the nitrous acid nitrite ion buffer. From the previous slide, we know that in order to prepare a nitrous acid nitrite ion buffer with pH 3.7, the concentration of the base component, that is nitrite ion, should be twice as much as the concentration of acid component, that is nitrous acid. We can pick any two values that satisfies this relation. For example, I pick nitrite ion concentration to be 0.5 molar and nitrous acid concentration to be 0.25 molar. How do you prepare such a solution which is 0.5 molar in nitrite ion and 0.25 molar in nitrous acid? For the sake of simplicity, let us say we need 1 liter of this solution to be prepared. There are 3 ways to prepare this buffer in the lab. In the first method, we dissolve 0.25 moles of nitrous acid and 0.5 moles of sodium nitrite in less than 1 liter of water. When completely dissolved, transfer the solution into a 1 liter measuring cylinder and make up the volume to 1 liter mark. If you want to be more precise, we can use the volumetric flask to make up the volume as well. The final concentration of nitrous acid is 0.25 molar and nitrite ion in the solution is 0.50 molar. That is, concentration of nitrite ion is 2 times the concentration of nitrous acid, which was our goal to begin with. The second method is to start with a weak acid and add a certain amount of strong base to it. Earlier in the course, we learned that a weak acid reacts with a strong base to form its conjugate base and water. If we take the initial concentrations of the weak acid and strong base in such a way that the strong base is the limiting reagent and the weak acid is the excess reagent, the strong base will be completely consumed in the reaction, and at equilibrium we will have the weak acid and its conjugate base left over in the solution. This is exactly what we want to prepare. A buffer solution which is a combination of a weak acid and its conjugate base. Now let us see how to calculate the initial amounts of the weak acid and the strong base we need to mix to make the desired buffer. For this example, we start with nitrous acid and add sodium hydroxide to convert a part of nitrous acid into the nitrite ion. Let us set up the ice chart. Now, this ice chart is a little different in that we have the equilibrium concentrations and we are calculating the initial amounts. At equilibrium, we need 0.25 moles of nitrous acid and 0.5 moles of nitrite ion in the solution. That is, we do not have any hydroxide ion at equilibrium. We know that we are starting with 0 moles of nitrite ion. That means 0.5 moles of nitrite ion is produced in the reaction. According to the stoichiometry of the reaction, in order to produce 0.5 moles of nitrite ion, 0.5 moles of hydroxide ion should be consumed, and the same amount of nitrous acid should also be consumed. Therefore, at the beginning, we need to add 0.75 moles of nitrous acid and 0.5 moles of hydroxide ion. The procedure is very similar to what we have seen in the earlier slide. We dissolve 0.75 moles of nitrous acid and 0.5 moles of hydroxide ion in less than 1 liter of water. Once completely dissolved, transfer the solution into a 1 liter graduated cylinder and make up the volume to 1 liter mark. The third method is to start with a weak base and add a certain amount of strong acid to it. We know that a weak base reacts with a strong acid to form its conjugate acid and water. Now, if we take the initial concentrations of the weak base and strong acid in such a way that the strong acid is the limiting reagent and the weak base is the excess reagent, the strong acid will be completely consumed in the reaction, and at equilibrium, we will have a weak base and its conjugate acid left over in the solution. This again is a buffer solution. For this example, we can start with the base component, that is sodium nitrite, and add enough strong acid such as hydrochloric acid to convert a part of the base component into the acid component. Pause the video here and calculate the number of moles of sodium nitrite and hydrochloric acid we need to start with to make a buffer that is 0.25 moles of nitrous acid and 0.5 moles of sodium nitrite at equilibrium. Let us set up the ice chart. This ice chart is quite similar to what we have seen in the earlier slide. That is, we know the equilibrium concentrations and we are trying to find out the initial concentrations from it. At equilibrium, we need 0.25 moles of nitrous acid and 0.5 moles of nitrite ion in the solution and 0 moles of hydronium ion. We know that we are starting with 0 moles of nitrous acid. That means all 0.25 moles of nitrous acid is produced during the reaction. According to the stoichiometry, in order to produce 0.25 moles of nitrous acid, 0.25 moles of hydronium ions should be consumed, and the same amount of nitrite ion should also be consumed. Therefore, at the beginning, we need to add 0.75 moles of nitrite ion and 0.25 moles of hydronium ion. The procedure is quite similar to what we have seen earlier. We dissolve 0.75 moles of nitrite ion and 0.25 moles of hydronium ion in less than 1 liter of water. When completely dissolved, we transfer the solution into a 1 liter measuring cylinder and make up the volume to 1 liter mark.